Hello everyone, I'm Ken Smith with the Bosch Home Comfort Group. We would like to welcome you to the video training series on our Bosch equipment.
And I'm Fred Crick. We're going to take you through all the features and the benefits. The BGH furnace. We're going to take you through the installation manual, showing you the ins and the outs and the whys. You need to watch these videos. So welcome.
Hey Fred.
Hey Ken, how you doing?
Going good. What you doing over here?
I've got a brand new BGH Bosch furnace sitting on this cart, and I was just getting a little bit of the dirt and the grease off of it.
This is a condensating furnace?
It is a 96% furnace, which means it's going to condensate.
Okay, good. And what are the options, benefits, and features of this particular furnace?
So one of the main things is that we're going to always have to use a PVC type vent. No longer are we going to use Class B metal vent. Features on this particular machine is that it's going to come basically in a 4 different BTU packages, which means that we'll have 3 different widths to the furnace.
Okay, and you mentioned the 4 different BTUs, like a high, medium, and low. What are we talking about?
So yeah, so we're talking about literally a 60,000, an 80,000, and then a 100,000, and then a 120,000 BTU output.
Okay, good. And the different types of configurations or positions that the furnaces
oh yeah, absolutely.
Of?
So right now we're in the upflow application. We can go horizontal left, horizontal right. The only thing that this furnace can't do is be flipped over and blow the air down. So it is not a counterflow or a downflow furnace.
Okay. And we have multiple stages in as far as the heating mode goes?
We have a 2-stage gas valve. So that means that if this furnace was an 80,000 BTU on the model number, half of that would be 40,000. Mm-hmm. So when I'm in a W1 low fire type situation, the output is only going to be 40,000 of the 80. Half of that, yes,
half
sir.
of whatever the total BTU. Well, let's take the door off of this and let's see what we have inside here. Now I notice we also have our Bosch BCC 100 controller on this.
Yes, sir.
Configuration application.
So when I'm looking at this furnace, I've got 4 screws that are on the front side of this furnace, and to take the top panel off, I'm going to take the outside screws out, pull the bottom, slip the top down. Inside here I have several bags of plastic with items in it. One of them is the IOM.
Your installation manual.
Installation manual, just like you said. Not a knee pad.
Correct.
Okay, all right.
Mm-hmm. Some different parts and pieces included in that bag.
Ken, one of the nicest things that I have found about this furnace is what is in this bag right here. This is my come from the factory, shipped to the contractor. If I have a system going in an LP application, this furnace comes with the LP kit already in it. I don't have to go back to the distributor on a Friday afternoon and get it because I forgot to ask for it. It comes with the box.
That's nice. And liquid propane kit is included with the furnace.
Yes,
correct?
sir.
No,
yes, sir.
Not a separate SKU.
Not a
separate line item that you have to buy at the time of the purchase.
Absolutely.
Of the furnace. Correct.
So Ken, in this bag, I have hoses that goes from my secondary heat exchanger down to the collection port. The reason that I have hoses is that as I run the gas through the heat exchanger and I bring it back down into that secondary heat exchanger, that's when I'm going to remove all the moisture away from that gas, producing condensation just like this evaporator would be doing in the summertime, so I have to get rid of that water.
Correct.
That's why this unit is called a condensating furnace.
Correct.
And one of the nicest things that we've done in the past year and a half or so is we literally have now included your 60, 85, your different sizes of BTUs and the length of hoses. Now I can just go by this chart and I can cut the hoses off utilizing the reference sheet that comes with the unit. I don't have to guess anymore, just look at this and cut the hoses off accordingly. Each one of the hoses has a hose clamp to go. So again, all of the necessary items to take the water away from the secondary heat exchanger back down into the collection plate is included in this unit.
With this being a 90% condensating furnace and producing so much condensation in the furnace during the heating cycle, whether it's low fire or high fire, it's critical that we get all of this moisture, all this condensation out of this furnace. Is there, in the installation, does it explain having a little bit of fall in the furnace to get all of that water, moisture, condensation out of there?
Yes, sir. So in the manual, it is going to ask us to tilt this furnace, whether it's in an upflow application from the back toward the front, or whether it's in a horizontal situation from the back to the front. Always tilt it 3/4 inch to a 1/2 inch of fall, so that I get that water out of that collection plate. One of the things that we found out is that if we don't tilt it, we will not get the BTUs that the machine is supposed to be giving us in a high fire situation because of the reduction of BTUs that are left inside that. We will not get the fire out of it. So we do want to tilt that.
Correct. Oh, so now when we go to a horizontal left-hand service or right-hand service, we talked about it's vertical left or right, no counterflow. When we go to the left-hand or the right-hand service side, there are some things that we have to reposition and change in the furnace due to the service side that we choose for that particular application.
Absolutely. And what we're talking about on what is to be changed is where this collection box is going to be setting. We now have it basically applicated for right-hand side, or as we look at it, right-hand, left-hand side is the furnace sets collection box. We could actually put it over here on the other side. The other thing that is really nice about this furnace is that my E-box came over here on the right-hand side or the left-hand side looking at it, and I moved it over here when we set it on this training card. I moved it over here to this side, so there was enough wires inside here to be able to move the E-box from one side to the other. Same way with this, I've got enough hoses now. Once you set this up in an application, you're not going to move it, so cutting these hoses once, putting the hose clamps on there is going to be good for that application.
It's going to be done. In the horizontal left or horizontal right position, what are some of the changes that need to be made for those applications?
Okay, so right now I have my vent. This is what we call the bad gas. This is the combustion gas coming back in.
Fresh air. Yeah.
And so this bad gas, actually I can take it out of the top or I can take it out of the side. So if I'm laying it down horizontally, I can basically vent it straight out and then go out to my external exit point of the structure. But that's one of the nice things about this is that I have multiple places to bring the bad gas out of the cabinetry without having to cut any of the cabinetry itself.
Okay. Now, we were talking about in the different configurations, left-hand service, right-hand service, or upflow. If you'll notice, and you need to pay attention to your installation, your IOM, your installation manual, that when you do lay this down horizontal left or lay it down horizontal right, there are some changes that need to be made. One of those being the pressure switch has a negative and a positive side on it. In your manual, it will tell you whether you're left-hand service or right-hand service, how to reposition that pressure switch. There is also some drain changes that need to be made. Once again, this is a condensating furnace, so we're always going to have water coming out of it when we're in the heat mode. There's a yellow plug over here on your induced draft motor housing, and you'll notice in the installation manuals when you're going left or right that you need to disconnect the existing drain and reconnect it, and then remember to take the cap off of the new location and put it back on the old location, and just pay attention to those changes when you're going to lay it horizontal left or horizontal right. In the upflow position, you don't really need to change anything. Now, getting back to the cabinet sizes, Fred, let's kind of touch base on that for a minute.
Okay.
So you said we have the 60, the 80, the 100, and the 120. And what are the differences in the sizes of the physical cabinet?
Great questions. So this is a BGH96M 060B 3B. So in the 060, again, that's the BTUs for the output of the machine, okay? And the B stands for the width of the cabinetry. So this is a 17.5 or 17 and a half wide furnace. The 80,000 is also going to come in the B width, but it also comes in the C width. So the C represents a 21-inch wide furnace, and the D represents a 24.5 width furnace. Nice thing about all of those three different widths is that my coil can match up your tonnages to those three different widths of our BGH furnace.
Also, let's say that I wasn't changing the coil, I was going to use the existing coil for whatever reasons that may be. That also means that we have a furnace to fit pretty much everybody else's coil also.
Absolutely.
Correct.
Absolutely.
Yep. Cool.
Absolutely. So let me tell you, let's go back just a little bit and let's make sure that I explain this black and white, what would be the power wire to the furnace. This particular furnace, in that it is a 120 volt furnace, meaning that I've got a hot and I have a neutral for the 120. The door switch down here, which is a protection part of this furnace, meaning that I can't run this furnace with the fan compartment opened up to and allow combustion air back into the ductwork and things. That L1 is passed through that door switch, and L1 is always tied to the black wire, meaning that this is a polarity sensitive piece of machinery. It'll light up and the lights will come on and the fan will work in the summertime if you have it reverse polarity, but when you turn it on for heat, the burners will not come on unless you get the polarity correct.
Correct. So black being your hot,
L1,
or your line one, and white being your neutral.
Absolutely. And the next thing that we need to talk about in that box is that this particular situation, in that I am a flame-proving rectification style system, I have to have a good ground.
The flame sensor
absolutely
reports to the ground,
absolutely,
and reports back to the motherboard to tell that we have flame.
Yep, absolutely.
That we can keep the gas on.
Yep.
Yeah, okay.
Absolutely. So Ken, let's take this bottom panel off, and I'm going to remove the two screws that are closest to the door switch. Lift up, take off. One of the things that we are going to notice, that when I take this furnace out of the box, I am going to have a bottom plate that is located on the bottom part of the furnace that I'm going to have to take off 4 screws out of it before I'm able to use it in a upflow return air bottom situation. If I am using it in a side return situation, I can leave this plate on there.
Absolutely.
It is insulated. It's ready to go. This is a very, very heavy piece of metal. Mm-hmm. It is a very, very heavy outside skin cabinetry furnace. But today, now I've got this bottom panel off. This is where all of my controls are. This is where my thermostat wires are going to come in into play, where I can hook it up to the board. And it also allows me full direction of my fan control, my board, and all the electronics part of that. This is where my transformer is located. But in my fan motor, I can take out 2 screws, slide it out if I need to, put it back type situation. But again, the bottom panel must be on this unit when this unit is in the heat mode.
Correct. Now, what are the options as far as, we know that static pressure and CFM are very critical. What are our options? What type of blower motor does this furnace have? And what options do we have as far as, selecting or adjusting CFM and static pressure?
Every furnace size from the 60 to the 120 is going to have a 5-speed blower motor. That particular, those different speeds allow us to dial in the comfort, dial in the CFM for the delta T that's coming through this unit, whether we're on a low cool call or a low heat call, we're on a high heat call or a high cool call. I can dial in the fan speed directed to the CFM and my static of my ductwork, basically dialing in somebody's comfort using using 4 speeds out of that 5-speed blower motor.
So that would be W1, W2 in heat, Y1, Y2 in cooling?
Yes, sir, absolutely.
Is there a specific CFM where this equipment performs better, or a recommended CFM per ton?
The great question. The idea behind that is going to be when I match my system up with my IDS product, we are still looking at that 350 CFM per ton. We're still looking at, in the winter time, we're still looking at a delta T, or what we would call a temperature rise from the return air to the supply air, based off of our gas pressure, based off of our firing of our W1, W2 type scenario. Ken, again, one of the nicest things about this furnace is that it comes with a orifice for LP kit. I don't have to go purchase anything or forget to purchase it or anything like that. This unit comes with the LP kit. This LP kit is for standard elevations.
Correct.
Is there anything that we need to do for a higher elevation?
Yes, there is. So the furnace, straight out of the box, is good for 2,000 feet above sea level and under. If there is a need for higher altitude applications, there is a chart that we follow that we have access to. There's a separate, there's a different orifice that needs to be installed for 2,000 to 4,000 feet above sea level, 4 to 6, and 6 to 8, and all the way up to 10,000. We actually have some furnaces in higher elevations in Colorado, and even some higher elevations in Arizona that are running the different orifices. And they may be LP furnaces or they may be gas furnaces.
Awesome. So Ken, I get a question probably 2 times a month talking about wiring up the BCC 100 to the IDS unit utilizing the gas-fired furnace. Because we have a red, a yellow, a green, a common, a power wire termination down here, or a terminal block, where we're going to bring those wires to the terminal on the BGH furnace. But the installation manual and also our quick start guides show us where the B wire, the reversing valve energizing wire, goes from the thermostat to the condensing unit, but it does not hook up on the board. So it is just a single wire nut that connects the thermostat to the outdoor unit and does not go through the board.
And the B terminal would be for in the heat pump cycle alone, when we're not using the gas furnace, we're running the heat pump only. B is energizing the reversing valve in the heating cycle.
Absolutely, okay. Absolutely. So again, this could just be an air conditioner and we could run a gas-fired furnace. But if we're running it as a heat pump, then we're going to energize that reversing valve in the heating mode, okay?
Correct.
One more thing about the control wires is that I have on my condensing unit a white wire, or what we would call a W wire. That W wire is going to come back into and hook up to my board on the W1 side of the board. Meaning that when I go into a defrost mechanism or my system drops below 5 degrees outdoor ambient temperature, that particular system is going to fire up the low side or the first stage of my gas valve, and it's going to fire up at that point in time.
So when we're in a heat pump configuration and we do initiate a defrost mode, there are different parameters for what initiates the defrost mode. When we go into the defrost mode, we're putting 24-volt signal on that white wire coming from the condensing unit going back to the furnace. We know that when we're in the defrost mode, we're actually in the cooling cycle.
Right.
At that point, for defrost, we're going to start blowing some cold air. So we send that signal back to our furnace to give us a low fire to temper that air so we don't get that blast of cold air in the house just during the defrost cycle. Once the defrost cycle is completed, then that 24-volt signal is taken away from the furnace and we go back to normal heat pump operation.
Absolutely.
Sounds good.
Absolutely.
Thank you for watching. If you want to learn more about reliable and energy-efficient Bosch products, visit bosch-homecomfort.us.